Lesson 2, the ratio test. I love the ratio test. The ratio test will be our final formal test to determine if a positive term series converges or diverges. Here is a quick overview of the ratio test. In the ratio test, we take a look at the limit as n goes to infinity of the ratio of the nth plus 1 term to the nth term. Let's call that limit L. And we compare that limit to the following criteria to determine if it converges, diverges, or if further investigation is required. So let's say that our L is less than 1. So if L is less than 1, then we conclude that the series is convergent, or the series converges. Now let's suppose that the limit is greater than 1. All the way up and including infinity. If the limit goes to infinity, or any case where the limit is greater than 1, we say that the series diverges or is divergent. The only one that causes us a little bit of grief is when the limit equals 1. That will tell us that further investigation is required. Example 1. Let's determine using the ratio test whether the series from 1 to infinity of 3 to the n over n factorial converges or diverges. Now I'm going to ask, when you use the ratio test, you draw a little heart. And a lot of people will ask, do I have to draw a heart? And the answer is yes. Other people will ask, if I don't draw the heart, will you take off points? And the answer is yes. So draw the heart. Ratio test. And I'm going to write it out. Ratio test. Okay, here we go. In the ratio test, we're going to denote the nth term, clearly 3 to the n over n factorial. We will also define or denote the next term, the nth plus 1 term, which is 3 to the n plus 1 over n plus 1 factorial. We first want to say that an is positive, remember it has to be a positive term series, on 1, 2, 3, ... where this 1 is because our starting at 1. And then we'll look at step 2. I'll take the limit as n goes to infinity. Now I would like you to please write the generic nth plus 1 term over the nth term, that ratio. And then this will equal the limit as n goes to infinity of 3 to the n plus 1 over n plus 1 factorial. Now instead of the division, I'll multiply the reciprocal. So then we have n factorial over 3 to the n. Now this really becomes an algebra lesson. Can you simplify this? Well, we're going to have the limit as n goes to infinity. We're going to take a look at these terms here. If I have 3 to the n plus 1 over 3 to the n, well, the 3 to the n plus 1 can be written as 3 to the n times 3 to the 1 over 3 to the n, which is simply 3 in the numerator. Next, I'm going to look at n factorial over n plus 1 factorial, and you should know that n factorial is n times n minus 1 times n minus 2 times ... times 2 times 1. And n plus 1 factorial is n plus 1 times n minus 1 times ... times 2 times 1. So everything will cancel out here. The n will cancel out, the n minus 1 will cancel out, and everything will cancel out except we are going to be left with 1 over n plus 1. So there we go. And this limit then comes out to be 0. Now we compare this limit to 1. If you recall, this limit 0 is now less than 1, so that tells us that the series converges. So I'll say, therefore, the sum from 1 to infinity of an equals the sum from 1 to infinity 3 to the n over n factorial converges by the ratio test. Example 2. Let's determine whether the series from 1 to infinity of 3 to the n over n squared converges or diverges using the ratio test. So I'm going to draw my heart and state ratio test. I'm going to say that an is 3 to the n over n squared, and I'm going to say the next term is 3 to the n plus 1 over n plus 1 quantity squared. I'll state that an is positive on 1, 2, 3, ... Step 2, we're going to take the limit as n goes to infinity of the nth plus 1 term over the nth term, which is the limit as n goes to infinity 3 to the n plus 1 over n plus 1 squared times the reciprocal n squared over 3 to the n. Here's where the algebra kicks in. So this is the limit as n goes to infinity. The 3 to the n plus 1 over 3 to the n will reduce to simply 3. Then when I have this n squared over n plus 1 squared, I'm going to write that as the quantity n over n plus 1 squared. Now this is getting a little fancy here, but I'm going to say 3 times the limit, or actually I'll put the limit inside employing a property of limits, n over n plus 1 quantity squared, which will then be 3 times 1 squared, or simply 3. Now we compare that limit of 3 to 1, and the limit of 3 is greater than 1. And so that tells us that the series diverges, as we have drawn here. It is interesting to note in this example that we could have actually done the nth term test, and it would have failed the nth term test, and we also could have concluded that it diverged by that reasoning, as seen here, using a little bit of L'Hopital's rule. Example 3, let's determine if the series from 1 to infinity, n to the n over n factorial converges or diverges using the ratio test. We state our nth and nth plus 1 terms. We state that an is positive, and we take the limit of the ratio of the nth plus 1 to the nth term as follows. But now we take a pause because the algebra is the trickiest part of the problem. See if you can work this out, and then unpause to reveal the solution. I'm going to write this as the limit n goes to infinity of n plus 1 to the n times n plus 1 to the power of 1. And I will put that over the n to the n, because what I have left are these two terms, which simplifies to be 1 over n plus 1. And I can see that these cancel out, and so I'm left with the limit as n goes to infinity. Let's just clean this up. N plus 1 to the n over n to the n. Now we have to determine what this does. So with a little bit of fun trickery, I'm going to say that this is going to be n plus 1 over n to the n. And so that I can see this even more clearly, I'm going to simplify the base to be 1 plus 1 over n to the n. Ah, behold! Do you recognize this limit? You should. This is going to e. Sweet. Now I compare e to 1, and e is greater than 1, so the series diverges. Diverges by the ratio test. Ah, suppose this was an examination. How many points would you earn if it were, say, I don't know, 10 points? You would earn 9 of the 10 points. What is this problem missing? Do you know? You're right. The heart. Ratio test. Smile optional. Example number 4 asks you to determine whether the series from 1 to infinity of 2 to the 3n plus 1 over n to the n converges or diverges, but it asks you to use something called the root test. The root test is not on the AP outline. In class, I will probably go over this, but for the purposes of this video, I'm going to leave this alone. Please note you will not need the root test for the AP exam.